All right. Now, finding the range of a rational function is, I don't want to use the word fun because you might not view it as fun, but it's certainly interesting and it brings back something that we've talked about in the past, right? Now, normally when we're identifying the range, right, normally we just want to look at the graph, right? And this is the most, the fastest way, should we say, to find the range, but it's got some pitfalls to it, right? So when we're finding the range of a graph, remember how we did this before? We said go to the lowest point, right, and trace the graph up, right? And wherever you have to pick your pencil up off the paper, that's an exclusion from the range. So we're going to the left, and you can see here, look at the y values. I know I'm going kind of fast. 1.893, 1.894, 1.895, 1 point, slowly, slowly, slowly creeping up, right? And so you could even take a look back at this original window and say, look at this value of 2, right? Doesn't it look like, if we come all the way over here, doesn't it look like this graph isn't going to cross, right, that line? So this is what we would call a horizontal asymptote. We're going to do some more work with horizontal asymptotes in the past. We can assume there's a horizontal asymptote here at this point when we come out to 50 and we're still at 2.066, right? So if you want to, I don't want to say cheat, but if you want to use what we used in the past and say, it clearly looks like there are no points that have a y coordinate of 2, right? And I could zoom out, pretty far, all the way out to 1400. When x is 1,396, the y coordinate is 2.002. So just barely above 2, right? Just on the other side of 2. And if I come over here to negative, let's see if I get to negative 1396, I'm at 1.998, right? So just barely under 2. So it's safe to assume, okay, and we don't like assuming in math class, but it's safe to assume that the y value is never going to be 2, right? Okay, and so we're going to start with that, but then like I said, I think this is going to be kind of fun to talk about. Y cannot equal -2. This is where we're starting our assumption, right, based on the graph. But one thing that we learned about range and inverses, if you recall, we said that when you take the inverse of a function, sorry, that's a really long one, but you get the idea. The inverse of a function, all right, and f of x, and you take the original function f of x. Remember that the domain of f of x becomes the range of the inverse and vice versa, right? The range of f of x becomes the domain. So one way to identify the range of any function is to find the domain of its inverse, okay? So what that means is you're taking this function and finding the inverse of this. Now, that process for something that looks as horrible as this, right? That would imply we're taking this and making this x, and we're taking the x's and making them y's, okay? Now, something like this is probably not going to be very fun to do this, right? It would start by multiplying the y squared minus 16 over to the other side, right? And multiply this side by y squared minus 16 so that we can get rid of this, right? I don't think we're going to go all the way through this problem. I just wanted to give you an idea that there is a different sort of, and I'm not going to say a sneaky way, okay, to find the range, but it's interesting to bring this back and say you can find the range of a rational function by finding its inverse, right? Now, how are we going to isolate and solve for y from this, right? It would be a total mess. So it's fun to talk about, right? The execution of it, probably pretty scary and pretty hairy to do that, right? So we're going to go with this assumption right off the bat that this can never equal -2, and we're going to say that the range goes from -infinity to -2, and then picks up again on the other side of -2 and goes towards positive infinity. So here's our range, right? Based on that idea of a horizontal asymptote. Right, and we're going to do more work with this in the future, okay? We're going to have some tests for figuring out exactly where that horizontal asymptote is, Okay, I can tell you definitively right now that yes, the horizontal asymptote is -2. So this is not an assumption. Okay, but based on just looking at the graph and eyeballing it, it's safe to say that. Okay, we're going to have some tests in the future that make this a little bit more clear and definitive. So, long story short, you want to find the range. You want to give yourself a baseline. Look at the graph, right? Trace all the way down and keep tracing on this graph until you get to wherever you believe you'd have to pick your pencil off the paper. Zoom all the way out. We're all the way over to here, right? And we're still not quite to 2. And then come over here where the graph picks up again, and we're on the other side of 2, right? Okay. So use the graph. It's your friend when you're trying to find the range of a function.